So another thing I decided to do, let me be clear, I'm doing the exact same thing. I'm not doing anything different. But for today, I'm going to display it differently. I'm going to organize it differently to see if maybe it'll make some sense to some people, because I could tell by the few people I helped yesterday in the lab that for some of you it's just not sticking in, and so maybe by arranging it on the page differently, maybe it'll start to make sense to you. Just we'll try it. If you understood, it's the same thing. I'm not. Let's make this clear. I'm not doing anything differently, but I'm just gonna write it differently. See if it makes any sense. So here we need to graph, and then we have to answer some questions about the graph. So here's the big difference that I'm gonna do. Instead of doing writing it in coordinate notation, I'm gonna go back to the table. We started kind of off doing a table, but it's gonna be like a weird, like a little bit of a weird looking table. Gonna make it look like that. Here I'm gonna write X. Here I'm gonna write Y, and I'll write something in the middle shortly. The reason why I wrote the X and the Y on the outside is those are the parent points. What type of function is this first one? It is exponential, and it's a base 3. So the base is where you get your parent points from. I'll go ahead and write 4 points. I don't know if I'm going to fit all 4 points, but I'll write 4 points. With a base that's greater than 1, what are probably the best points to pick? Yeah, 0 and positive, so like 0, 1, 2, 3, and we're taking 3 to that power. So 3 to the 0 power is 1, 3 to the first power is 3, 3 squared is 9, 3 to the third is 27. If you don't like this way, you don't have to use it. I'm just trying something different just to try to reach everybody. Same thing I did before. Just instead of writing it in a set of parentheses, I'm writing it this way. Okay? Now let's get the transform point. That's what's going to go in the middle. Okay? In order to get the transform point, I need to know my transformation values, which in this case, let's see, A, C, H, and K. It's hard to fit everything here. A is 2. C is 1. Who said 3? H is, and K is. So what I'm going to do here is I'm going to get all of my x's. Now I'm supposed to divide by c, but c is 1. If you want to put x divided by 1, you can, but it's not going to do anything. So all I got to do is get all my x's and take away 4. That's what H says to do. For all of my my y's, I'm going to go times 2, which is A, and then minus 2, which is K. And those are the numbers I'm going to get in the middle. So 0 minus 4, negative 4, negative 3, negative 2, negative 1. All these y's, 1 times 2 minus 2 is 0. 3 times 2 minus 2 is 4. Put it in the calculator if you want. I don't need a calculator because I'm awesome. I just took turns taking all the... Yes, sir. C would be here. It would be dividing. C is up on the exponent, whatever is the coefficient of the x, whatever is right in front of the x. So if up here, like let's say this would have said 3 to the 2x plus 4. What's C? 2. And then another thing that caught them, look, this is going to be very rare. Like, you're not going to see a lot of C's. People don't put a lot of C's on quizzes, but you need to be aware of it. It showed up on the homework. Anytime C is not 1, you have to factor it out. You need a parenthesis. So like in this case, I would have had to factor it out to 2. This becomes x plus 2. So, and like C is still going to be 2, but in this case, what would H have ended up being? No. Negative 2. H would have ended up being, it has an effect on what H is. But yes, for the most part, you know, people then ask me, is C always going to be 1? No, not always, but yes, usually it's very common that you don't have to deal with C. So the points I'm going to plot now are in blue. I've conveniently color-coded this for you. They're going to be in blue. I need an asymptote. What type of asymptote do we have on exponentials? It is going to be horizontal, and it's going to be at y equals k. Yep. Here at, ew, I don't like that. I like blue. And if you want to write that in, you could even write that in if you want here. My asymptote is at y equals -2. So let's see, -4, -1, no, sorry, -3, +4, -216, which I ran out of space already. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm gonna be somewhere up here, and it's enough to sketch. That's good enough. We know more or less how it'll look. What is the domain of any exponential function? Every single one. Yeah, if you get this wrong, for you, all real numbers. Now when we go to logarithmic, what becomes all real numbers? The range, yeah. Now what's the range here? It's a lot easier. There will be some where they might ask you this without the graph, but with the graph it should be a lot easier. Yeah, -2 to +infinity. Transformations, I don't have enough space to write them out, but we can say them verbally, and you can fit them somewhere on your paper. How many total transformations are occurring here? 3. Good. What are they? Let's start off with the stretches and reflections first. Let's leave the translations to the end. You don't have to, but it's just I like doing it that way. Good. Vertical stretch of? Oh, look at Stephanie. She told you, Victor. Good. Vertical stretch of 2. And then? Horizontal translation? No. Left 4. Yeah, H is horizontal. Even if you don't write the word horizontal, as long as you write the word left, left implies horizontal, so you can just say translate left 4 units, and then a translation down 2 units. Those are the 3 transformations. Okay, intervals of increase or decrease. Anytime you're talking about intervals, that ties in directly with the domain. Okay, this does not change any direction, so this is going to be either increasing or decreasing throughout the entire domain. Which one is it? Is it increasing or decreasing? Yeah, this is increasing throughout. If that were a roller coaster and you're going to the right, you're going to be going up forever. Intercepts. Okay, the key here is to make sure we know how to do this algebraically. Oh, I'm sorry. Thank you. Yeah. No, you're right. Sorry, I meant to do this. Increase, and then -infinity, +infinity. Thank you. Let's make sure we know how to find the intercepts algebraically. How do we find an x-intercept algebraically? Plug in a 0 for y. So let's do x-intercept. And then, oh man, I don't know if I'm going to fit this y-intercept. So for the x-intercept, plug in a 0 for y. So 0 equals 2 times 3 to the x plus 4 minus 2. In order to solve for x, I would do +2 first, which gives me 2 equals 2 times 3 to the x plus 4. Then divide by 2. So 1 equals 3 to the x plus 4. Now that I've isolated the base, how do I get rid of the base? Log base 3 on both sides. I don't have that much space, so I'll just write down that log base 3 of 1 is equal to x plus 4. What is log base 3 of 1? That can be evaluated. Use change of base. What's log 1 divided by log 3? It has to be 0. Thank you. If we had a calculator out, we can use our community calculator to verify that. -4 minus 4. And at this point, some of you may be realizing, oh wait, duh, it was on the graph. Yeah, well, we purposely, for the test and quiz, picked points that are going to be outside the window so that you can't see them on the graph. You need to know how to find it algebraically. What? If A is greater, A is always vertical. C is always horizontal. Okay? If A is greater than 1, anytime either of them are greater than 1, okay, I know this is not going to do well on the video because you can't see me, but anytime either of those greater than 1, it's doing this. It's going this way, right? So if it's coming from A, how would you describe that motion vertically? It's getting stretchy. Okay? But now if C were greater than 1, it's still doing this, but how would I describe this horizontally? Yeah, because it's getting skinnier. Sure, if I'm doing this, it's also getting skinnier, so it's a horizontal compression if C was greater than 1. If A was between 0 and 1, the negatives have nothing to do with it. Negative has to do with it if it's a reflection. So if A is a fraction, it's doing this, squishing, right? How would I describe that vertically? Compression. So if it's coming from A, you would say vertical compression. But then if it was coming from C, if C was a fraction and I was doing something like this, it would be a horizontal stretch. Yeah. I mean, kind of. They're complementary, I guess you could say. They work. They're in cahoots. And then finally for the y-intercept, you put in a 0 for x. So 2 times 3 to the 0 plus 4 minus 2. That's 2 times 3 to the 4 minus 2. 3 to the 4th, I believe, is 81. Check my math. So 2 times 81 minus 2, I'll do the rest in my head, is 160. So when we come up here, the intercepts are negative, no, yeah, I had it right. Negative 4, 0, and then 0, 160. Did I go too fast there? That part was just really from the last test, like it's just knowing how to solve a logarithmic or exponential equation. Okay, and behavior, your favorite. No matter what, even if you were living under a rock for the last 3 months, okay, you should know that this is going to start off with x approaches, comma, y approaches, y approaches. X means left and right, y means up and down. So with regards to the x-axis, what is the left arrow doing? It is going forever to the left. But then as far as up and down, simultaneously, what's that left arrow doing? It's going down to negative 2. It's not going to go any further than that. How about to the right? What's happening with x to the right? Yeah, even though it looks like it's going up, but what are you talking about? It's going straight up. If you give it enough space, if you were to pinch it and zoom out enough, that would eventually, it'll get to positive infinity eventually. It'll take forever, but it'll get there. And then what's y doing at the same time? That's a little easier to tell. Also positive infinity. Any questions there? I'm going to erase this because I don't have enough space. So let's move on to the next one. How is this a little bit different than the first one? This one's a decay. Okay, so just to change things up, if you liked doing it with coordinate pairs, do it that way. I'll just trying to reach all the students. I'm going to use a table. On the outside, I'll put my parent points. On the inside is the juicy part that I'm going to graph. What would be some good inputs to choose here? Yeah, 0 and negatives. Not because I have to. The domain is all real numbers. I can pick whatever I want. But if we're trying to avoid fractions, probably be a good idea to pick 0 and negatives. What is 1/2 to the 0 power? 1. What's 1/2 to the negative 1? 2. I would hope by now you know why this is the case. I've explained this multiple times. But if you don't, stick it in the calculator then. I mean, literally just put 1/2 to the negative 1, 1/2 to the negative 2, and do it that way if you don't understand it by now. What's 1/2 to the negative 2? 1/2 to negative 3 is 8. So these are going to be my parent points, but then I got to transform these. In order to transform them, and I need to identify the transformation values. So here, A, C, H, and K. A is? No! -1, good. C is? Good. H is? 2. K is? Facts. The X is supposed to be divided by C, but C is 1. If you want to write here, look, watch here, let's get crazy. There you go. For everybody, there you go. X divided by 1. If you want to see it, that's what C does. And then plus 2. The Y is times A, which is -1, plus K, which is 4. Then I'm going to use my mental math skills. This gives me 2, 1, 0, -1. This gives me -1 plus 4, which is 3. -2 plus 4, which is 2. -4 plus 4, which is 0. -8 plus 4, which is -4. I'm graphing the inside one, the blue ones. What type of asymptote does a exponential have? Where is this one going to be at? Yeah, K, which is at 4, so Y equals 4 is going to be my asymptotal. There we go. Now we can plot the points. 2, 3. 1, 2. 0, 0. -1, -4. That's enough to get a nice definition on the little curve there. Bam. Abby, what's my domain? Yeah. If it doesn't say log, if the variable's inside a log, it's logarithmic. If the variable's up in an exponent, it's exponential. No, Abby? Too hard, domain? Yeah, it's all right. How much math is involved? If you've been paying attention, how much math is involved in the question I just asked? If I did this and said, hey, number 2 is exponential, what's the domain? Yeah, all exponentials are the same thing. Negative infinity to positive infinity. Now the range does depend. What's the range here? Negative infinity up to 4. For transformations, how many total transformations do we have here? 3. They are? Okay, well, we call it an x-axis reflection, but fine. If you were to put vertical reflection, I'd probably take it. X-axis reflection, what else? Yep, A being -1. You just said vertical to the right. Horizontal translation, 2 units to the right, and vertical translation, 4 units up. That would be there. Is this increasing or decreasing? If this were a roller coaster and you would be going to the right, it would be increasing. And it's increasing everywhere. And let's just do end behavior and then we'll do intercepts afterwards. End behavior. What's the left arrow doing? Negative infinity, negative infinity. What's the right arrow doing? Positive infinity, and then 4. Okay, now let's do the intercepts. I mean, we can tell from the graph already that they're both going to end up being 0, but let's prove it. X-intercept, Y-intercept. For the X-intercept, you put a 0 for Y, so 0 is equal to negative 1/2 x minus 2 plus 4. So I got to go minus 4 minus 4. Negative 4 is equal to negative 1/2 to the x minus 2. I multiply by negative 1 to get rid of the negative in front. So I get positive 4 is equal to the 1/2 of x minus 2. Now that the base has been isolated, how do you get rid of that base? Log base. Yeah, log base 1/2. So log base 1/2 of 4 is what's equal to x minus 2. So put in the calculator log 4 divided by log 1/2. That should give you negative 2 is equal to x minus 2 plus 2 plus 2. 0 is equal to x. Now we put in that same 0 for x to find the y-intercept. We would say y is equal to negative 1/2 to the 0 minus 2 plus 4. So y is equal, 0 minus 2 is negative 2. Negative 1/2 to the negative 2. I'm sorry, not negative 1/2. The negative stays on the outside. The negative's on the outside. What's 1/2 to the negative 2? Because it's 4. So you end up with negative 4 plus 4, which also gives you 0. So that makes sense. Both intercepts here are at 0, 0. Yes, sir. X-axis. When it's vertical, think of it like if it was like a piece of string that it was tripping over. It would be tripping. In order to flip vertically, you have to trip over the x-axis. I personally would accept vertical unless I'm told otherwise by the powers that be that I'm not allowed to accept it. I would. It's always been taught to you as x-axis. So I don't know why there's a reason why you wouldn't put x-axis. Any questions there? All right. These are some of the bigger ones I wanted to get to. Not because you're gonna see it a lot, and technically not because you shouldn't know how to do it, but you haven't seen them a lot on the notes before. Zora, what type of a function is this? No. Where do you see the variable? Where do you see the input variable? It's up in an exponent, so it's exponential. But what's slightly different about this? What would cause confusion and people's heads to explode? Huh? The base is e. And e is an irrational number. So there's going to be a lot of calculator involved here. Now, here's one thing I do know, Abby. What's the domain going to be? I didn't start with this before, but let's just start with it now. What's the domain going to be? It's going to be a smile. What's the domain? You want me to ask Mohammed? Let's see Mohammed. Let's see if he knows. And he's been sleeping on. There you go. Look at that. He's been sleeping for the past 2 weeks, and he knows all your numbers. Yep. That's where we draw our inspiration from Mohammed. But like, so yeah, when we do this whole table here, this is where it's gonna get it's a lot of calculator. We're gonna have to use a lot of calculator because we're gonna need to graph. So now, with that being said, even though e is irrational, we do have an estimate of what e is. What is e approximately? It is not 1.0 something. 2.71. E is approximately 2.71, and is 2.71 greater than 1, or is it less than 1? Greater than 1. So what should be some good inputs to use? 0 and positives. Okay. But now we're gonna need to use the calculator. So I know e to the 0 is 1 because anything to the 0 is 1. I know to the 1 would be around 2.71. Help me out there. Just put e to the second power. Tell me what you get. Should be 5 point something, maybe 6. E squared. Somebody help me out. We need to use calculator. Huh? Yes, yeah, because this is only for graphing. So 7.4. Okay, it's possible. Yeah, I guess 7.4. Fine. And then what What's e to the third? 20.1? Better not be lying to me, Zora. We'll find you. No, I trust you. I'm just playing with you. Gabby can't be trusted, but Zora we trust. Let's identify our transformation values. A, C, H, K. A is 2, C is? Dennis, what's C? Good. What's H? Ah! Good. And then K is -3. So we're not doing anything with C or H. Sweet. So all the X's are going to stay the same. This is just going to stay as X. So all the transformations are going to happen with the Y's. It's going to be the Y times 2 and then -3. So I know the first one, 1 times 2 minus 3 is -1. 2 times, here, since Zora didn't give me 2 decimals, it's all Zora's fault. I'll just change this to 2.7. It'll make it easier for my mental math. What was the next one? 7.1 it was? 7.4. Alright, so 2.7 times 2 is 5.4 minus 3 is 2.4. 7.4 times 2 is 14.8 minus 3 is 11.8. 40.2 minus, that's going to be too big to graph anyways, but whatever. 37.2, something like that. I'll just graph the first 3. Where's my asymptote going to be? Y equals -3. Excellent. Well played, sir. And then it's just, so 0, -1. Oh, wait, where do I find 2.4? Just in between 2 and 3. Just get it close. In between 2 and 3 somewhere. 2 and 11.8. That's like up here somewhere. So here's my graph. Bam. Finito. Range. ¿Dónde está el rango? Who said that? Moosey? Moosey's been eating almond joys. He's on point today. Dennis, where's my asymptote? Good. Make sure you put the y equals. I guarantee if you put x equals on that, it's going to be wrong. Cade, how many transformations do we have here? Cade. Which ones are they? Vertical stretch, good, of 2, yeah. Caitlin will help. No. What? Yeah. Vertical translation 3 units down. Victor, question? Uh-huh. Yeah. Is this increasing or decreasing? Is this increasing or decreasing? Increasing. It's increasing everywhere. I think I've done enough end behavior, so I'm going to just skip that one. You can do that on your own, but I do want to focus on intercepts. What would something look like if it's decreasing? That's decreasing. That's decreasing. Think of it like a roller coaster, and you always had to be going from left to right. That roller coaster would still be going up. These roller coasters that I just drew right now, those would be going down. Here's Zora. We got to put the hair though. Yeah. There's the going down. That's Zora going down the roller coaster. If it's a roller coaster, always. Oh. I just like to draw. You're welcome. For x-intercept, what do we do? Plug in a 0 for y. So 0 equals 2e to the x minus 3. And then here will be y equals 2e to the 0 minus 3. Hey, let's do y-intercept first here. It's easier. What's e to the 0? It's what? It's 1, yeah. 2 times 1 is 2 minus 3. Y equals -1. And that made sense. We already knew that from here. So we know that one intercept is going to be at 0, -1. But then over here it gets a little bit, you just got to know what you're doing. Plus 3, so 3 equals 2e to the x. Since we're already in decimal land, when we do 3 divided by 2, we can just put 1.5, the heck with it. And then Zora the Explorer, how do you get rid of a base of e? Very good. So we just end up with ln of 1.5 is equal to x. If you were to leave it as ln of 1.5, I don't have a problem with that because it's irrational. But if you want to have it rounded, what's ln of 1.5 if you want to have an idea? 0.41? No, that's fine, 0.40. I think I even like ln of 1.5 if you just leave it exact better, but see, because like for the purposes of physically actually graphing it, yeah, you need to round because you need to know where those points go. But for the purposes of finding an intercept, if we're just doing it algebraically, you might as well just leave it like that. Okay, other page. Let's skip the next one and then go here to the second one on the page. Okay, these are logs. So what we do with logs is take advantage of the fact that we know that these are inverses of exponentials. Zora, do you know why this is a log? A logarithmic function? Yeah, and not only does it say log, the variable is inside the log. That's the more important part of it. So the trick here, Victor, is that just like exponentials, logs also have bases. What's the base here? 2. But when you're coming up with your set of parent points, don't put the inputs on the x's, put the inputs on the y's. So like this base is greater than 1, so I'm going to still use 0 and positive, but I'm going to use 0 and positive for the y's. They're inverses. Inverses, you switch the x and the y. Okay? And then by doing this, this allows me to now think in terms of exponentials as opposed to logs. We don't think well in terms of logs, but exponentials are more conducive to mental math. What is 2 to the 0 power? 1, so I'll put it here. What is 2 to the first power? What's 2 squared? What's, there you go. And then that's it. Once you have this, it's the exact same thing as exponential, with one little twist. This is the asymptote. Yeah, these have vertical asymptotes, so we would put x equals, and it's not going to be at k, it's going to be at, so I guess we should probably do that next. A, C, H, K. What's A here? No. -1, good. What's C? 1. What's H? What's K? Good. So it's where's the asymptote going to be at? X equals 1 because it's at H. We're doing the second one. Exponential functions, horizontal asymptote at y equals k. Logarithmic, vertical asymptote, x equals h. It's at h. Here, I'll even skip ahead and draw that for you. Boom. Okay, now let's go do our transformations. Okay, for the x's, we divide by c, but that's not going to do anything. And then we add h, that will do something. So I'm going to go get all of these x's. And let me ask, do any of you guys like it better like this as a table? Does this help you make it more sense than with the parentheses? I really don't care. I've always done parentheses, but if it helps you understand it, I know other teachers do it something more simple. Whatever you want, man. It's fine with me. I can grade it either way. So I just get all those x's that are right next to it in black, and I add 1 to it, coming from the h. All the y's that I have here are going to be times -1 and then plus 4. So 0 times 0 plus 4, -3, 2, Negative 3, 1. I mean, the log would have, the base of the log would have to be a fraction. I don't think I've even, it's possible, could, but I don't think I've even seen one. I wouldn't worry too much about those. All right, so now let's plot those points and let's see what it looks like. 2, 4, 1, 2, 4, 3, 3. Don't get the asymptote confused with the axis. 5, 2, 1, 2, 3, 4, 5, 2. Zora, I think you're gonna get your wish. 9, 1. So 2, 3, 4, 5, 6, 7, 8, 9, 1. So just for Zora, let's skip to that one. Is this increasing or decreasing? It's decreasing. But before we put the interval, I guess we should go backwards. What's the domain here? Yeah, don't just automatically put all real. The all real numbers here goes on range. The domain is to the right of the asymptote, so it would be from 1 to positive infinity. Transformations, this is independent. Like the transformation part, it doesn't even matter that we're graphing log or exponentials or a parabola, whatever it is. It's just saying, do you know how to interpret what these values mean? This is an x-axis reflection. Yep. Translation 4 up and translation 1 to the right. Yeah. This is going to be decreasing through the entire interval in the domain. Just basically repeat the domain. It doesn't change direction. M behavior, let's just do M behavior verbally. Sorry. What's the left arrow doing? Actually, you know what? Let's do M behavior for this one because this is a little bit different. This is the first time we do a logarithmic. And if I don't write it, you won't write it. So I'll write it. What's the left? With respect to the x-axis, the left arrow is going to 1. It's not going to go any more left than 1. What? And then what? With respect to the y, what's it doing? Don't you dare carbo load up in here, Randy. Only water is allowed inside the classrooms. And then what's the right arrow doing? Positive infinity for the x. Negative infinity for the y. Because it's going down, it's decreasing. X-axis reflection, translation 1 unit right, translation 4 units up. Okay, for the intercepts. X-intercept, Y-intercept. For x-intercept, we got to put in a 0 for y. So we put in 0 equals negative log base 2 of x minus 1 plus 4. For the y-intercept, we put in negative log base 2 of 0 minus 1 plus 4. What's the easier one of these two? And the y-intercept, because you're going to take the log of a negative. This is going to be an error. You can even tell by looking at the picture. This will not touch the y-axis. Once you do 0 minus 1 and you try doing log base 2 of negative 1, you're going to get an error. But this looks like it will touch. It should touch the x-axis eventually. So let's see when that happens. Minus 4 minus 4. So negative 4 is equal to negative log base 2 of x minus 1. I got to get rid of the negative. So if I multiply by negative 1, that knocks out this negative in front. Same thing here. So I get 4 equals log base 2 of x minus 1. How do I get rid of a log? How do I get rid of a log? Change to exponential. So now 2 to the 4th is equal to x minus 1. 2 to the fourth is 16 equals x minus 1 plus 1 plus 1. 17 is equal to x. So it's at 17, 0. That's the only intercept we have on the x. There's no intercept for the y. I wanted to do this next one, but my warning came out. I wanted to skip to some of the stuff on the next 2 pages, which are just more quick identification stuff, because I know that on they're gonna be easy questions, but you're gonna botch them up because they don't involve graphs. It's more like matching and writing. And are there any questions as to how I got that 17? All right, so let's skip to the now. What I don't have videos that go with this, but I do have a key. And I posted that on my e-class already. So if you want to work on this also over the weekend, if you want to do that last one, you can see it on. I posted the key up. This is another E. Okay, so let's go to here. Let's go to the bottom. Write an equation of a logarithmic function that has a vertical translation down 3, a horizontal translation left 1, and a vertical reflection over the x-axis. So A, C, H, K. What would A be? -1. It doesn't say anything about a stretch, but it does say an x-axis reflection, so -1. What would C be? 1. What would H be? If you're going left 1. -1. What would K be? -3, because we're going down 3. This has to be logarithmic, so you would write either f of x equals or y equals negative log, because that's where the A goes. Then you don't have to worry about C. It would be x plus 1, because you got to change the sign for the H, minus 3. It's not an exponent. It is logarithmic. It's inside of a log. That's why I wrote log. Okay, let's look at number 10. Now this is an exponential function. A, C, H, K. With a base. Okay, so this one they're actually telling you what they want the base to be. Okay. On this other one, for the log, they didn't say it, so I guess you could have made it any type of base log. What base did I end up with the way I wrote the log? 10, good. But this one has to be base 5. Vertical translation down 2, what does that mean? K is -2, good. A horizontal translation right 3, what does that mean? H is +3. A reflection over the y-axis, what does that mean? -1, and what does a vertical compression of 1/4 mean? Where? A is +1/4. So there's a lot of things. We have all 4 transformations here. A, C, H, and K are all doing something. I would start off with y equals. First comes A, which is 1/4. Then comes the base, which usually when you have an A, you write the base in a parentheses. What do they say they want the base to be? 5. Now this becomes a little bit tricky. You see how C is not 1? So I have to write a parentheses on the exponent also. So I'm gonna have to write the negative, then the parentheses, and then on the inside x -3, change the sign of H, and then out here -2. If you distributed the negative, know that as long as you end up, if you're gonna take out the parentheses and leave just the negative x, then the 3 has to be positive. That would be fine also. Okay, let's do some quick matching here. We have 2 logs and 2 exponentials. First thing you should be looking at are the asymptotes. Okay, the ones that have horizontal asymptotes at the top, which ones do those have to be? These 2 that have the horizontal asymptotes, those have to be which type? Exponentials, right? So and look, especially with the time being the way it is, what we have left, I'm not even going to go into too much, elaborate too much, because like we can literally just tell these just by the asymptotes. We don't even have to go into bases or transformations. So here, the 2 exponentials are B and D. Which one has the asymptote at -1? D. So this first one here is D. Okay. If you look at the other one, it confirmed the horizontal asymptote is at 2, so this one's B. These other ones that are logarithmic. Okay, yes, this is the shape of a logarithm, but just look at the asymptote. If you know, ideally that's the easiest way. Which one has it at -3? And remember, with the asymptotes, you're looking at h. No, you're not looking at k. You're looking at h. Which one has it at -3? A. Good. Because remember here you change the sign, and then this would make this c. All right, these are really good ones here. And this will be the last at the end. What is the domain? This is exponential. What is the domain and range of this? Well, exponential, the domain is always all real numbers. But the range, but mister, how can I tell what the range is? You know, I can't see a picture of it. What does the range depend on? The asymptote. So the question is just, is it above the asymptote or below? Well, that depends on if a flip occurred. Did an x-axis flip occur here? Yes, because that negative is not attached to the base. That negative is out in front. You can't have a negative base on an exponential. It wouldn't be continuous. So because it flipped over, okay, now we're not going to positive infinity. We're going to negative infinity. So this would be from negative infinity up into the asymptote, which is, yeah, on exponentials, it's k, so up to 3. For logs, the range is going to be negative infinity automatically. It should be 100%. But now we have a vertical asymptote, and that depends on h. But now it also depends on who cares if there was a vertical flip, if there was an x-axis flip. We care if it flipped over the y-axis on c. Is c negative there? No, so we're going to be to the right. We have to be to the right, so we're going to be going here from -4, because for h is -4, up until positive infinity. You're not going to have a ton of those, but you might have some. And these should be the easiest ones here. What's the asymptote on that logarithmic one? X equals, because it's vertical, 1. What's the asymptote on the last one? Very good. If you understood everything I did today, there's no reason why you shouldn't have an A tomorrow. No other questions? So again, look, the key is posted for this. There's no videos that go with this, but the key is, there's only like, what, a couple problems that we didn't do, maybe 3 problems that we didn't do. And then the test review, if you wanted to work on that, yeah, those have videos posted. If over the break or whenever, if you have any questions on any of this stuff, you can always send me a reminder.